You ever stop and think about the sheer magic happening inside your computer? How it can possibly do a million things at once? Well, today we're going to pull back the curtain on that magic trick. We're diving into how operating systems juggle everything from your music to your web browser without breaking a sweat.
I mean, it feels impossible, right? How can one single brain, one CPU, focus on so many different things simultaneously? It seems like it should just grind to a halt. But it doesn't, all thanks to a brilliant illusion orchestrated by the operating system.
So, to understand this illusion, we need to meet the star of the show. And it's not the program file just sitting there on your hard drive. No, it's something much more alive.
It's what we call a process. A process is a program that's been brought to life. It's an active thing, running and actually carrying out its instructions. Think about it like this. Your music player app is the blueprint. But the process? That's the music you're actually hearing.
Now, how in the world does the OS keep tabs on all these active processes running around? Well, every single one gets its own little digital ID card. It's called a process control block, or PCB for short. This thing is absolutely critical. It holds everything the OS needs to know, like its ID, its current status, you name it.
You know, you might think a process is just either on or off, but its life is way more interesting than that. It actually goes on a whole journey through a series of distinct stages, a life cycle with 5 key states.
First, it's new, while the OS is just getting it set up. Then it moves into the ready state, basically waiting in line for its turn. Once the CPU gives it the green light, it's running, and it's finally doing its thing. But sometimes it has to pause and go into the waiting state, maybe for a file to download or something. And finally, when its work is all done, it becomes terminated.
That ready state is super important. Imagine a really busy deli counter. All those ready processes are just standing in line, holding their little tickets, just waiting for the CPU to call their number so they can get their moment in the spotlight. And here's the kicker. This is the whole challenge in a nutshell. Even with all those processes lined up and ready to go, if you only have one CPU core, only one process can actually be in that running state at any given microsecond. That's the fundamental rule that makes all this multitasking stuff so tricky.
So, if only one thing can run at a time, how does anything actually get done? Well, this is where the operating system steps in. You can think of it like the master director of a movie, constantly moving processes between these states to create that flawless illusion of doing everything at once. The first big move, that's from ready to running. It's called dispatch. The OS scheduler, the real brains of the operation, picks a process from that queue and basically says, all right, you're up. And just like that, it's that process's turn to use the CPU. But what if a running process suddenly needs something, like data from the hard drive? It can't just sit there twiddling its thumbs and hogging the CPU while it waits. So it does the smart thing. It voluntarily moves itself from running to the waiting state. This is called blocking. And boom! The moment that file download is complete or the data arrives, the process gets a signal. It's unblocked. The OS then moves it right back into the ready queue, ready to get back in line for its next turn on the CPU.
But the OS is a fair boss. It won't just let one greedy process run forever. It actually uses a timer. And when a process's time slices up, wham, the OS preemptively yanks it off the CPU, even if it's not finished, and puts it right back in the ready queue. This is how it makes sure everybody gets a fair shot.
This incredibly fast swapping act has a name. It's called a context switch. In a flash, the OS freezes the current process, saves all of its progress right into its PCB, and then loads the state of the next process from its PCB. This happens thousands of times a second. It's wild. But, and this is a really big but, there's a cost. While the OS is busy playing traffic cop and doing one of these context switches, it's not actually running any of your programs. This time is pure, unadulterated overhead. Let's be really clear about this. The amount of useful work, the stuff you actually care about, that your computer does during a context switch is a big, fat zero. The whole goal is to make this switch so blindingly fast that you never, ever notice it's happening. All right, so we've seen the life cycle, we've seen the states, we've seen all this frantic switching. But why? Why go through all this trouble? Why is this elaborate juggling act so ridiculously important? Well, this entire system is literally the bedrock of modern computing. It's what lets us run a bunch of programs at the same time and ensures fairness so no single app can hijack the whole system. And by keeping the CPU busy working on something while other processes are waiting, it squeezes every last drop of efficiency out of your hardware.
Without this, your computer would basically have a one-track mind. So these principles are happening right now, on your device. But now, just for a second, scale that up in your mind. What happens when it's not a dozen processes, but millions, all being juggled across massive data centers in the cloud? Well, that's when the art of juggling gets infinitely more complex.